Hi, I am Seek. Let us look at some exciting stuff. Have you ever experienced an earthquake? Do you know what causes it? An earthquake is the shaking of the Earth's surface caused by movements of its tectonic plates. During an earthquake, ground-shaking seismic waves radiate outward from the quake source called the epicenter. The source of an earthquake is the rupture that occurs due to geological faults like volcanoes, landslides, etc. How do you determine how massive an earthquake is? We can measure an earthquake to know the magnitude of the earthquake using a seismograph. The magnitude of an earthquake is the amount of motion produced during an earthquake. Along with the motion, waves of energy called seismic waves occur through the Earth's crust and transmit outwards from the focus of an earthquake. A seismograph is a device used to measure the intensity of an earthquake. The seismograph works by recording the movement as it happens. Let us understand the concepts related to seismographs. Seismographs work on inertia and can detect quakes that are too small for humans to feel. Seismographs are securely mounted to the surface of the earth, so when the ground starts shaking, the instrument's case moves. What doesn't move, however, is a suspended mass inside the seismograph. This is called the seismometer. During an earthquake, the seismometer remains still while the case around it moves with the ground shaking. Traditionally, the suspended mass was a pendulum, but most modern seismometers work electromagnetically. A large permanent magnet is used for the mass, and the outside case contains numerous coils of fine wire. Movements of the magnet relative to the case generate small electric signals in the wire, which can be sent to a computer or recorded onto paper to create a seismogram. Different types of seismic waves travel at different speeds and through different parts of the earth during a quake. The farther seismic waves get from their source, the weaker they become. A network of interconnected seismographs can quickly pinpoint the source of a quake by measuring differences in the time it takes different seismic waves to reach a detector. Because seismographs can only measure movement in one direction, many seismograph stations have multiple seismographs to record the north, south, east, west, and vertical motions of the ground. These measurements allow scientists to estimate the distance, direction, magnitude, and the type of earthquake that just occurred. With most of the earthquakes happening underwater, the ocean bottom seismometer is designed to measure movement underwater. The seismograph body rests securely on the seafloor. Inside, a heavy mass hangs on a spring between two magnets. When the Earth moves, so do the seismometer and its magnets, but the mass briefly stays where it is. As the mass oscillates through the magnetic field, it produces an electrical current which the seismometer measures. After this activity, you will be able to understand the importance of seismographs, design a model of a seismograph, and simulate an earthquake to record readings.